For quantitative purposes, K equilibrium is used to characterize the given equilibrium system. But if you had to qualitatively characterize it, say for example, if you had a reaction sulfur trioxide in equilibrium with sulfur dioxide and oxygen, right? How do you qualitatively characterize it? In other words, if this equilibrium were to be disturbed, what will happen as a consequence of that disturbance? This answer to this question is given in a principle called Le Chatelier's principle, and this is what we'll learn in this video. So, using the equation sulfur trioxide gas in equilibrium with sulfur dioxide and oxygen, and all the reactants are gases. One more piece of information that is given to you is that delta H is 98.9 kilojoules. Now what does this delta H mean? Now delta H is the information about energy changes in the reaction. So if delta H is a positive number like this one here, it's an endothermic reaction. What does that mean? That means that energy is absorbed. Okay, endothermic reaction, energy absorbed. So as the forward reaction takes place, temperature of the system decreases. Temperature of the reaction vessel decreases. But if delta H is negative, that means it's an exothermic reaction, and that as the reaction goes in the forward direction, temperature of the reaction vessel increases. Right? Now, going back to our equation, sulfur trioxide gas is in equilibrium with sulfur dioxide gas and oxygen gas, and delta H is a positive number. How much ever this number is, this positive tells us that it is endothermic reaction. Now you take that reaction vessel in which this reaction is going on, it is now at equilibrium, and what do? You place it in boiling water. So what you're doing is you've taken a very happy reaction that's at equilibrium and you're changing its condition. You place it in boiling water. So what this system will try to do is it will try to undo this effect. In other words, you have increased the temperature of the system. It will try to decrease the temperature. It will move in a direction either forward or reverse and try to decrease the temperature. Now, if this reaction, remember, is an endothermic reaction. So when it moves in what does that endothermic mean? It means that as it moves in the forward direction, temperature decreases. What is the objective? Because you created that disturbance by increasing the temperature, the system wants to decrease its temperature. So what will it do? The equilibrium will shift in the forward direction to decrease the temperature, and that's how it counteracts the disturbance that you have made. Okay, and these kind of disturbances can be made in terms of temperature that we have just done. You can disturb pressure, you can disturb concentration. Okay, say for example, same reaction, SO3 in equilibrium with SO2 and O2, right? So what you can do is, you can take this reaction vessel, start the reaction, wait for the equilibrium to begin, and once this equilibrium is established, you can disturb this by removing oxygen. That's one kind of concentration disturbance. So what have you done? You disturb the system by removing oxygen. So the system does not like that, because it was at perfect equilibrium and you removed oxygen and you disturbed that equilibrium. So what will it try to do? It will try to get back to that equilibrium by making more oxygen. So to make more oxygen, which way does the equilibrium need to shift? It needs to shift in the forward direction. So to re-establish that equilibrium, the system will shift in the forward direction, and so as a result of that shift, more sulfur dioxide and more oxygen are produced. And this is an example of concentration disturbance.